You ever get that feeling like when you look up at the night sky and you see all those stars, and you feel incredibly small, like a tiny speck in this vast universe.
Yeah, it's humbling, isn't it?
Totally. And kind of awesome at the same time. Well, today we're diving into that feeling, that sense of awe. We're going to explore the structure of our cosmic neighborhood, trying to get a handle on this mind-boggling concept of a universe.
We're talking about Nebadon.
Nebadon,
our local universe.
Our local universe.
Yeah.
You mean like there are others?
Well, there are others, countless others, according to the Urantia Book. That's our source material for this deep dive, by the way.
The Urantia Book, yeah, always full of surprises. So, okay, countless universes. Let's unpack that a bit. I mean, how do we even begin to understand something that vast?
Well, imagine for a moment, not physical boundaries, but an energy field, a life force pervading everything. The Urantia Book calls this the creative spirit.
The creative spirit.
The creative spirit and its influence. That's what defines the borders of a local universe like Nebadon.
Okay, so not like a physical wall or anything, but more like this sphere of influence emanating from this creative spirit.
Precisely. It's about the reach of this creative energy, not some arbitrarily defined boundary.
Okay, I think I'm starting to get it. So Nebadon is this energy-defined space shaped by the creative spirit. That's pretty wild, but if there are all these other universes out there, each with its own creative spirit, I'm guessing, did it always exist? How did it even come to be?
Another great question. And, the answer might surprise you. Nebadon, it wasn't born from a single event, not like a big bang or anything.
Right.
It's actually, think of it like a cosmic melting pot. Remnants of multiple ancient nebulae, each with its own history, its own unique characteristics, all coming together.
A cosmic melting pot. I like that. So Nebadon is kind of like a blend of different cosmic ingredients.
Exactly. And the Urantia Book even gives us a name for one of these ancient nebulae, Andronover.
Andronover. Wow. It makes you wonder what sorts of stars and planets might have formed from that ancient mix. But if Nebadon is just one of many, where does it fit in the grand scheme of things? Like, is there some sort of super-duper universe?
There is. It's called a super universe.
Mm-hmm.
Ours is Orvanton. And just like our planet orbits the sun, Nebadon, it orbits a central point within Orvanton.
Whoa, wait a minute. So we're talking about layers upon layers here. Okay, I need a metaphor. Give me something to help wrap my head around this.
A metaphor.
Yeah?
Right, I like it. How about this? Think of Nebadon as a bustling city.
A city. Okay, I can see that. Lots going on, constantly evolving.
Exactly. And that city, that's Nebadon. Now, that city exists within a state, which would be our super universe, Orvanton.
Okay. And is that state, is it part of a country, like a really, really big country?
You got it. The country represents the grand universe. That's the big picture, encompassing everything.
Okay, I think I'm starting to see it. But that brings up another question. With all these cosmic structures, all this movement, all this energy, what's keeping everything running smoothly? What's the organizational structure here?
Well, that's where we get into some really mind-bending stuff. The Urantia Book describes these forces, these incredible forces, called supreme power centers. They essentially act as the universe's energy regulators.
Supreme power centers, it sounds like, I don't know, like a cosmic version of like a power grid or something.
Kind of, but on a scale you can't even imagine. We're talking about receiving raw power, like unimaginable amounts of energy from a source as vast as a super universe.
Wow.
Modifying it and then distributing it throughout an entire local universe. That's their job.
So these supreme power centers, they're like the ultimate energy managers, making sure everything stays powered up.
You could say that. They are fundamental to the very fabric of the universe, these forces.
But where are these power centers located? Is it like a giant cosmic power plant somewhere?
Not a power plant, no. But the Urantia Book does tell us they operate from a place called Salvington. Salvington. It's the headquarters, so to speak, of our local universe, Nebadon.
Salvington. It sounds like something out of a fantasy novel. So there's this place, the Salvington, and it's like the cosmic control center for Nebadon. That's amazing.
It is. And get this, there are 100 of these supreme power centers on Salvington.
100?
100 working in unison.
Wow. Okay, so we've got Salvington, the headquarters, with its 100 supreme power centers managing the energy grid of Nebadon. It's a lot to take in. But I have to ask, is Salvington the only one? Are there other places like it out there?
The Urantia Book mentions other architectural spheres. Dentia, for example. That's the headquarters of our constellation of stars.
Wait, so our solar system is part of a constellation?
It is. It's part of a local system called Satania.
Satania.
Yes. And Satania, it's part of a larger constellation of stars with its own headquarters, Urantia.
Okay, so it's like levels of government, but for the universe.
It's a good way to think about it. And
Yeah.
then there's Jerusalem.
Jerusalem?
That's the headquarters for our local system, Satania.
So we've got Salvington for Nebadon, Urantia for the constellation, and Jerusalem for Satania. Wow, that's a lot of levels of cosmic bureaucracy. But are these places, are they powered by stars?
Actually, that's one of the most fascinating things about them. They don't rely on stars for their energy. They're powered independently.
Independently? How does that even work?
Oh, that's a question for another deep dive, perhaps. But for now, let's just say the universe has ways of providing.
Okay, I can live with that bit of mystery for now. But if these supreme power centers are managing the energy on a grand scale, I mean, is there someone or something actually like directing that energy on a more local level, making sure it gets where it needs to go?
Another great question. And that's where the concept of master physical controllers comes into play. Think of them as, I don't know, like the middle management of the universe.
Middle management, huh? Keeping the cosmic gears turning. I like it.
Exactly. They work with those supreme power centers we talked about, making sure the energy is distributed effectively within their designated jurisdictions. And our jurisdiction, that would be Satania.
Okay, so each local system, like Satania, has its own master physical controllers, kind of keeping an eye on things.
Precisely. And one of the things they oversee is quite interesting. The Urantia calls it a dark island.
A dark island? What is that?
It's a region of incredibly dense matter. So dense that it doesn't emit light the way a star does.
So it's like a black hole.
Not a black hole, but it does have an incredible gravitational pull. And the Urantia book suggests that these dark islands, they play a critical role in how energy is distributed throughout a local system.
Fascinating. So even the darkness has a purpose in all of this. But if these master physical controllers are responsible for directing the energy, I mean, do they do it themselves, or is there something else at work here?
Well, the Urantia book describes beings called energy manipulators.
Yeah.
They work under the guidance of the master physical controllers.
Mm-hmm.
It's like, well, imagine being able to fine-tune the energy flow on a planetary scale.
You're saying they can actually manipulate energy to influence the conditions on a planet?
It's certainly a possibility, isn't it?
Wow. Okay. This is getting more and more interesting by the minute. So we've got this incredible system for managing and directing energy throughout the universe. But what about the stars themselves? Where do they fit into all of this? So last time we were talking about those incredible energy manipulators, kind of like the cosmic electricians, right? Making sure the energy gets where it needs to go.
It's a good analogy, but, it's easy to get caught up in the grand scheme of things, the overall energy management of the universe.
Totally. But what about the stars themselves?
Exactly. I mean, we take our sun for granted.
But it's always there, right?
Right. But it's not just this static thing in the sky. The reality is it's far more dynamic.
Dynamic? How so? You're not going to tell me the sun has a personality, are you?
Well, the Urantia book does describe it as having a life cycle.
A life cycle? You mean like it was born?
In a sense, yes. Stars, they're born, they evolve, and eventually they die.
Whoa, okay. Hold on. So stars, they're not just these eternal things. They don't just burn forever.
Nope. They have a finite lifespan, just like us, although their timelines are a bit longer.
A bit. You're talking about billions of years, right? So what does that mean, a star dies? What happens? Does it just go dark?
Well, it's a bit more dramatic than that. But before we get to the grand finale, let's talk about our sun.
Okay.
We tend to think of it as this giant ball of fire, but
Which, I mean, it kind of is, right?
not exactly. See, fire, as we know it, requires oxygen.
Right, of course.
And there's not a whole lot of oxygen just floating around in space.
That's true. So what's happening inside the sun? If it's not burning, how is it generating all that energy?
The Urantia book tells us that stars are powered by something far more powerful, far more fundamental: the annihilation of atoms.
Annihilation, like completely gone.
Gone. Reduced to pure energy. EMC4,
Right. Einstein's famous equation.
Exactly.
Yeah.
It's the ultimate example of that at work. Matter, even something as tiny as an electron, can be converted into an unbelievable amount of energy. We're talking billions of nuclear bombs every second.
Every second. Wow. Can't even wrap my head around that. But so all this energy is being generated at the sun's core, right?
Yeah.
How does it actually get to us here on Earth? Does it just beam straight out?
Not quite. Remember those X-rays we talked about earlier?
Huh?
The ones generated by the annihilation process?
Yeah.
They actually play a key role in transporting that energy from the core to the surface.
So the same forces that are, like, blasting these atoms apart are also responsible for carrying that energy outwards. It's like a cosmic two-for-one deal.
You could say that. But here's where it gets really interesting. The Urantia book describes this process called random walk that these X-rays undergo as they travel.
Random walk, that doesn't sound very efficient.
Yeah.
I mean, for a process that's so vital, shouldn't it be more, I don't know, direct?
It might sound chaotic, but there's an order to it. Imagine a single X-ray, right, a photon, trying to escape the core.
Okay.
It bumps into a particle, gets deflected, collides again, and on it goes.
Like a cosmic pinball machine.
Exactly. And it can take hundreds of thousands of years for a single photon to make its way from the core to the surface.
Hundreds of thousands of years. So the sunlight we're feeling right now, it's ancient.
It is. Isn't that amazing?
It's mind-blowing. But once those photons, once they finally break free, then what?
Then they're racing through space at the speed of light, reaching us in a mere 8 minutes.
From a cosmic crawl to a light speed sprint. Wow. Okay. That's incredible. But you mentioned earlier that stars have a life cycle. So what happens when a star like our sun, what happens when it reaches the end of its life?
Remember how we talked about the sun being incredibly dense?
Yeah.
As it burns through its fuel, a star like ours, it'll actually start to expand outward, becoming what's known as a red giant.
A red giant. How big are we talking?
Big. Potentially big enough to engulf the orbits of Mercury and Venus.
Wait, seriously? You mean, like, there's a chance the sun could actually swallow up Earth?
Well, while the Urantia book doesn't give precise measurements for our sun's expansion, chances are Earth will likely survive.
Okay.
But it won't be pleasant. Let's just say you'll want to have your sunscreen handy.
Right, a bit of an understatement. So after the red giant phase, then what? Does the sun just stay that way forever? A giant blazing inferno?
Eventually, it'll start to shed its outer layers, kind of like a cosmic snake shedding its skin.
Okay.
And what's left behind, its core, that'll compress into this incredibly dense object called a white dwarf.
A white dwarf. So it's like the sun goes on this extreme cosmic diet, right? Shedding billions of tons of material.
You could say that. And that white dwarf, even though it's much smaller than the sun is now, it's still incredibly hot, incredibly dense.
Wow. So like a cosmic ember, just kind of slowly cooling down over billions of years.
Exactly. But that's just one way a star can die. For stars much larger than our sun, well, the end is far more dramatic. We're talking supernovas.
Supernovas, those are like the rock stars of the cosmos, right? Exploding in a blaze of glory. But what causes that? Is it just a bigger, brighter version of a red giant expanding?
It's not just bigger and brighter, it's a completely different beast altogether. See, for a star much more massive than our sun, eventually the core, it collapses in on itself. And that collapse, it triggers this runaway nuclear reaction, an explosion of unimaginable power. We're talking about an event that could outshine an entire galaxy for a brief time.
Talk about going out with a bang. But besides the light show, what else happens during a supernova? Does anything survive?
Actually, supernovas are incredibly important. They're the universe's way of, well, recycling. The intense heat and pressure during these explosions, they create elements heavier than iron. Elements that wouldn't exist otherwise.
Heavier elements, you mean like
Gold.
gold,
Yes.
silver?
Exactly. And, carbon, oxygen, nitrogen, the very building blocks of life as we know it.
Wait, seriously. So the calcium in my bones, the iron in my blood, it all came from exploding stars.
In a very real sense, yes.
Yeah.
We are literally made of stardust.
Okay, I am speechless. That is officially the coolest thing I've learned all week. But okay, so a supernova happens. It scatters all these elements across vast distances. How do they eventually come back together? How do they form new stars, new planets? It's like going from a wildly exploding fireworks show to a perfectly choreographed ballet. It's like going from a wildly exploding fireworks show to a perfectly choreographed ballet.
I like that. So from supernova to solar system, huh? How does that actually happen?
It's a beautiful analogy, and you're right, the process is surprisingly elegant. Picture this. A vast cloud of gas and dust, remnants from those supernova explosions we were talking about. The Urantia book calls them cosmic nebulae, and they're scattered all throughout the universe.
Okay, so we've got these like clouds of stardust just floating around. What's the catalyst? What gets the whole star-forming process going? Gravity. Gravity is the ultimate architect. Over vast stretches of time, These particles, drawn together by their own subtle gravitational pull, they begin to clump together.
So it starts small, like with tiny particles drawn to each other, kind of like how dust bunnies form under my couch, but on a cosmic scale.
Exactly. And as these clumps grow larger, their gravitational pull, it intensifies, drawing in even more material. Eventually, this cloud of gas and dust, it collapses in on itself, forming a dense, rotating core.
And that spinning core, that's what eventually becomes a star.
Exactly. The pressure at the core, it becomes so intense, the temperature so unimaginably high that hydrogen atoms, they begin to fuse together, releasing this tremendous amount of energy.
And that's the moment a star is born, right? When nuclear fusion ignites at its core. It's incredible. But what about the planets? How do they form from all this swirling chaos?
Well, the Urantia book offers a fascinating explanation for the formation of our own solar system. It describes this close encounter between our nascent solar system, back when it was still forming, and another much larger star system called Angona.
A close encounter? Like a cosmic near miss?
Exactly. Imagine these two swirling systems, each with its own gravitational pull, passing close to one another. The result, it'd be like a gravitational tug-of-war, flinging these massive amounts of stellar material out into space.
So our solar system was essentially born from a cosmic fender bender. That's not what I was expecting.
It's a pretty dramatic origin story, for sure.
Yeah.
And while the Urantia book doesn't specify exactly how common these close encounters are, it seems to suggest they play a significant role in the formation of many solar systems.
But wouldn't an encounter like that just create a lot of chaos? How do planets end up in stable orbits after something like that?
That's where the incredible balancing act of gravity comes in. Even amidst all the chaos of a near collision, the laws of physics, they still apply. They operate with incredible precision. So, over millions of years, those scattered remnants, those clumps of matter, they gradually settle into these stable orbits around the newly formed star, finding a kind of gravitational equilibrium.
It's amazing to think that something as destructive as a near collision could actually lead to the creation of something as ordered and complex as the solar system.
It really speaks to the power and the elegance of the universe, doesn't it? But it's important to remember that our understanding of these processes, it's always evolving. What we know today, it's based on observations, simulations, and yes, even texts like the Urantia book, which can offer these really intriguing perspectives that often challenge conventional thinking.
Absolutely. And speaking of perspectives, I think it's time to zoom out again. I mean, we've talked about our sun, our solar system, our local system of stars, Satania.
Mm.
How does all of that fit into the grander structure of Nebadon, our local universe?
Right, back to the big picture. Well, it turns out that our little corner of the universe is, how do I put this? A bit off the beaten path, you could say. The Urantia book tells us that Satania is located on the outskirts of Nebadon, far from the hustle and bustle of the central regions of our local universe.
So we're not exactly at the center of the action, are we?
Not quite. But, I kind of find that humbling. I don't know about you. Here we are, this tiny planet, orbiting an average star, in a relatively quiet corner of a vast, bustling universe. And yet here we are, capable of contemplating these cosmic wonders, unraveling the mysteries of our own existence. It's pretty amazing when you think about it.
It really is. And on that note, I think we've reached the end of our deep dive into the cosmic tapestry of Nebadon. It's been, to say the least, a mind-expanding journey.
I completely agree. It's been a pleasure exploring these amazing concepts with you.
And to all our listeners out there, thank you for joining us on this cosmic adventure. If you'd like to dive deeper into any of the ideas we've explored today, we highly recommend checking out the Urantia book. It's a fascinating read full of surprises. And until next time, keep looking up, keep asking questions, and never lose your sense of wonder.